Hey guys, welcome to Unit 3, Section 1, Crystal Formation. We're going to go through the first part, actually part 1 and 2 of the notes. What is a crystal and crystal size and shape? I'm going to start off with a picture of the Nika Caves that you guys have seen already. You guys have talked about it. You have an idea of how they formed from water. What we're going to do with this section is talk about how they formed, why they're the size they are, that sort of thing. So first off, crystal formation. We should probably define what a crystal is. We did talk about it with the do now. Crystal, we know it's either crystalline or amorphous. A crystal, biggest thing here, you need to understand that it's a regular, it has a distinct pattern, regular repeating arrangement of atoms. Okay. You also order is that big key term. Amorphous, no order. With crystal, there is a specific structure that we're looking for. Usually, we like to crystals are easily identified by their external plane faces. The shiny face is the thing that reflect. You saw them with your monoclinic. You could see the reflection to help you find those small rod-like crystals that they created. So one of those, actually, that's right, monoclinic. That's one of our example. You can put down monoclinic, sulfur. Obviously, you see snowflake next to you. I wanted to just put that one up there because you can see the repeating pattern. That branching goes on and on and on over and over again. So repeating pattern, big part of it, and we'll talk about that in a second. Other examples, well, all ceramics have crystals. All metals have crystals. You saw my bismuth crystal, obviously, but there are some other things that you may know. Salt is a crystal. Sugar is a crystal, right? There are some other examples over here. Interesting things. This first one in the green are actually kidney stones. Crystals are all throughout our body, including DNA. DNA is considered a crystal. You can see that repeating pattern over and over again. We know exactly its size and shape, again, because of that, repeating pattern. This picture right here is a picture of a DNA strand, the double helix from the top. This crisscross bar there. This was a X-ray diffraction picture taken by Rosalind Franklin. It was actually used by Watson and Crick to show that structure of the DNA and figure out how it was created. So that repeating pattern, that crisscross there, we could see going down all the way. Other examples, you guys know, obviously, diamond is a good example. These crystals are from the Smithsonian Institute in Washington, D.C. When they're guys, if you ever get a chance to go to the Natural History Museum, the Smithsonian Natural History Museum, absolutely gorgeous. The geodes and gem room, it's amazing. The amount of it. This is the most colorful, which is why I chose this one. But the amount of different crystals they have there is awe-inspiring. This one is also another one that they have there. It's just fun to look at. It looks like a fiber optic net, doesn't it? But one you may not have realized, chocolate, tempered chocolate, the chocolate you get in your candy bars, is actually crystal in structure too. When you have dull chocolate, like the baking chocolate that you may or may not have seen, that comes from many different crystals mixed together. So you don't see it. They're ordered. That's why you have the different shapes here. They're not ordered. You see this if you ever have had chocolate melt and then refreeze on you. It has that strange dull color. It looks like it's bad. It's not bad. It's just not in the large crystals like tempered chocolate is. Here you can see those little crystals forming their larger crystals. Okay, actually these purple things are what we call a unit cell, which is what we're going to talk about next. A unit cell is your most basic form of a crystal. Okay, it is your smallest arrangement of atoms that can be repeated to form a particular crystal. So sort of drew this on the board with salt. This is your basic, okay? What happens is they start building and building on each other. Those unit cells are known as building blocks, and eventually you have larger and larger crystals that will go on to shape the large crystal itself. And it's whatever that building block is. This happened to be square, so your large crystal would look square, but if it was rhombohedral, it would look rhombohedral. The bismuth crystal is not quite a square. If you can see, let me move out of here, grab a pen, we'll go to red so we can actually see it. You see the square repeating often in this crystal. Okay, these are unit cells and they're building off of each other. This is one grain, one large crystal, and it's that unit cell. You see that pattern over and over and over again. That's because it's based on that same repeating pattern. Okay. Why are these two crystals different sizes? How did this one get so big? Well, it all has to do with the cooling. All crystals come from a solution of some kind, and their shape, first of all, this is part 2, right? It depends on their internal symmetry. So the one we had just a second ago, you had the square and then the rhombohedral for the second one. So that's the shape that you're going to get when you do your single crystal, your copper sulfate crystal. Somebody asked if it would look like the seed crystal. It will. That's exactly what it should look like, and it's because you're building off of the same thing. Now, size of the crystal has to do with how quickly it can grow. Okay. If it cools quickly, that means it's going to be small grains. Okay. But if it can cool slowly, that means you're going to get your large grains. So this guy back here, he had a longer time to cool and he could build up on himself, while these guys cooled relatively quickly and you couldn't see anything. If you looked at the bottom side of it, it was sort of dull. You couldn't see any crystals, any of those repeating units. That's because it cooled so quickly. That's the outside of the metal. Cooled so quickly that the crystals are microscopic. Okay. When I think of this, I usually think of igneous rock because it's a great example. You have molten rock cooling either as it comes up out of the earth or it gets stuck in the middle of the layers. If it comes out, that means it's going to rapid temperature change, going to cool quickly, so you can see this fine grain. You can't even tell what the individual minerals are in this rock. You just know it's there. Pumice, same thing. But underground, where it's still actually relatively warm, okay, compared to the air outside in our atmosphere, you can see that the crystals can grow on each other and actually cooler. This one may have had more time than this one, since you can see larger grain crystals. It does depend on what mineral you do have, though. Okay, so that's it for right now for Section 1, Part 1 and 2. What is a crystal and how they form. We're going to go ahead and pause now. Take some time to check over your different labs and come back and do Part 3.